All right, getting into our third lesson here, exploring slopes using similar triangles. On the warm-up here, it just says for each diagram, describe how you can show the triangles are similar. Well, for that first one, we know they share a right angle. They both have a right angle. And this angle up at angle A is a shared angle that has to be congruent to each other. So, because they have two angles that we can confirm are congruent to each other, we can say they are similar using angle-angle similarity theorem. Okay, we could do the same for number 2. We know they share this angle in, so there's one angle that is congruent. And then if they're telling us that PQ is parallel to MR, we know that side PM is a transversal cutting through those two parallel lines, which makes this angle at angle P and this angle corresponding angles, and corresponding angles are congruent. So again, they are similar because of the angle-angle similarity theorem. We can have two angles that we can confirm are congruent, means we have similar triangles. All right, so getting started activity here just says consider the 3 street signs. What might you see with each one of these signs? So with each one, we're showing either an increase of a hill coming up or a decrease of a hill coming up along this road. So one, you might say, before a steep hill, we'd see this sign. For the second one, and I'll label these 1, 2, and 3. This would be before a steep decline. And the third one also might be before a steep decline. Okay, so what do we know about these triangles on the side? Well, they do look like they are right triangles. Looks like there's a right angle on each one of them. And they might be similar, but we're not sure. So might be similar. But unsure. And 3, for the signs that include numbers, what do we think those numbers might be? So they're giving us a percent. So if you know how hills are measured, it'd be a percent grade, which is just the steepness of the line. So those numbers probably represent the steepness or the grade of the hill. All right, so on to activity 3.1, triangles and the equation y equals mx. So said in that previous lesson, lesson 2 before, Jack and Jill went up a hill. We used patty paper to analyze the slope of that line, y equals 4/3 x. We just drew it on the video using similar triangles formed at x equals 1, x equals 3, and x equals 6. So it says now let's investigate if the slope of a line is always the same between any 2 points. So first one says, is the slope of this line positive or negative? Well, the line is increasing from left to right, so it is a positive slope. It is increasing. And for 2, it says examine the slope between points in A and B. Create a right triangle using points A and B and trace it onto patty paper. I'm just going to draw it on our graph here. So between A and B, I can create that right triangle. It says label the triangle with the vertical and horizontal distances. Well, my horizontal distance there looks like 4 units. My vertical distance looks like 1, 2, 3, 4, 5, 6. So 6 units. Then C says label it with the slope of the line between points A and B. Well, rise over run, 6 over 4, can be reduced to 3 over 2. So our slope would be 3 over 2 between points A and points B. Okay, so if we move on to 3, it says, does the orientation of the right triangle matter? So if we were to have this traced on patty paper, if you're doing it on paper, we could use point A as the center of rotation and rotate your triangle 180 degrees. So if I go back to this drawing, this was rotated 180 degrees, we would end up with the triangle on the opposite side over here. Look roughly something like this. But that wouldn't change the slope of that line. It would still match. So it says compare and contrast how these two triangles, how are they the same, how are they different? The horizontal and vertical distance remains unchanged. So the slope of that line does not change, unchanged. Okay, B, does the new triangle give you the same slope? Yes. That ratio of rise to run is still 6 over 4, which reduces to be 3 over 2. All right, now it tells us to create right triangles using points B and C, and then B and D, and then label the horizontal and vertical distances and find the slope. So I'm going to go back to that graph, and it said, let's see, B and C, and then B and D. All right, so B and C first. Here would be B and C, and then B and D would look something like that. So if I zoom in, horizontal distance for that blue triangle between B and C would be 2. Vertical distance would be 3. So again, we get a slope of 3 over 2. If we check the green one, 1, 2, 3, 4, 5, 6. So just like the red one earlier, and then horizontal is 4. So again, we get a slope of 6 over 4, which reduces to be 3 over 2. So we get the same slope all along that line. So if we go back down here, we labeled the slope of that line, we labeled the horizontal and vertical distance, and I would just make note, the slope remains 3 over 2. Okay, if we move on to number 5, still working with these triangles, it says compare the triangles created on the line. How can you verify all of the triangles are similar? Well, we can say that all have right angles. So we have an angle for sure that is shared, that is congruent, and congruent corresponding angles. So, in other words, if I go back to that graph, we could say that the line is a transversal cutting through, there's a transversal cutting through parallel lines that these triangles are making. So, if I zoom in here even farther, erase that stray mark, what we can say is this angle here would correspond to this angle, because those yellow lines are forming parallel lines, and then the original line there on our graph makes it transversal. So we have congruent corresponding angles. So we've now confirmed we have a right angle that is congruent in each triangle, and we have corresponding angles that would be congruent. So we have two angles that we can confirm are congruent. So we can confirm that they are similar triangles using the angle-angle similarity theorem, just like we did back on the warm-up. So what is the slope of the line? Just like we mentioned before, that slope was 3 over 2, or if you divide that, we have a slope of 1.5. All right, number 7, Cooper claims that all right triangles formed on a given line are similar. Is he correct? He is correct. Yes, because on a given line, that would always be the case. All would have one right angle. So the right angles would be congruent, and a pair of corresponding angles. And again, we'd have two congruent angles equals similar triangles. Because that third angle then has to be congruent if two of the three are congruent. All right, moving on to activity 3.2, triangle slope, and now we're looking at adding a b value to that equation, y equals mx plus b. So given a graph here, and it says, is the slope of the line positive, negative, and explain our reasoning. So again, this is another positive slope because it is increasing from left to right. And two, create at least three similar triangles using points on the line. Use any method to justify that these triangles are similar. So we're going to go pick out a few points here. I'm going to make one triangle here. There's one right triangle. So it'd be 1 and 2. Let me make that a little smaller print. 1, 2. There we go. Okay, and then I'm going to change to blue. I'm going to say here is a triangle. And this would be vertical of 4, horizontal of 2. And let's make an even bigger one. Let's make a green one here. And that would have a horizontal length of 4 and a vertical length of 8. So each one of those, if we divide, 8 over 4 equals 4 over 2 equals 2 over 1. They all reduce to divide and give us 2. So the slope of that line is 2. So our slope equals 2. And any method to justify these triangles are similar. It's just like the other ones we see. Any right triangle drawn along a line is going to be similar triangles because they share a right angle, and they're also going to be sharing corresponding angles that are equal to each other. So on the next page, how many similar triangles can be formed on a graph of a line? Well, there would be infinite. If that line goes on forever, we could draw an infinite number of right triangles along that line, and they would all have the same slope. So you could say all would have the same slope. All right, so determining slope of lines. We're going to find the slope of each one of these. So for A, our line is decreasing from left to right, so we know our slope is negative. And then if we pick out 2 points and draw our right triangle here, our vertical change there is 2, horizontal is 1. So 2 over 1, and we get a slope of negative 2. Okay, for the next one, B, we have a positive slope. This line is going up from left to right. It is increasing. So I'm going to pick out 2 points farther apart just to make it a little different. Our vertical change is 2. Horizontal change 1, 2, 3, 4. And 2 over 4 reduces to be 1/2 or 0.5. So the slope of that line would be 1/2. Okay, and then on the last page, talk that talk. Just something you can brainstorm here and fill in what your thoughts are. It says Audra was absent for the lesson excuse me, on the connection between similar triangles and the slope of a line. Write in your own words, write an explanation of what we've learned in this lesson. Be sure to include how you can use a graph to determine slope of non-vertical line and how you can use similar triangles to show that the slope is the same between any 2 points. So put into your own words an explanation describing how we can use those similar triangles to show the vertical change divided by the horizontal change, which gives us the slope, and that it's equal among any right triangle drawn.